library voice rule, that would be fantastic. Okay, you're here. Great. Cool. So who do I have? Jacob? Lindy's here? Are you, this is 10-4, section 4? Cool. You don't have to. You don't have to participate or anything like that. I'm glad you're here. Anybody else? Good news. Okay. Jacob looks like maybe you, me, and Thomas. Great. So, guys, really straightforward here. We're going to be talking about compound probability and disjoint events, but I'm going to use poker as a way to set this up. So, real life true story going on here. I'm in Las Vegas, and my friend and I are trying to kill time before our golf course reservation. We have a tee time, and there's like about an hour to go, so we're looking to kill an hour. My friend has this great idea, let's go sit at the poker table, we'll kill some time that way. And I'm not feeling it, right? Like, I don't feel like losing any money, I'd rather just kill some time. But I'd go along with it, and I decide, okay, I'll put $100 worth of chips down, and I'll try and just stay afloat and not lose too much money. So, I get down at the table, and I'm doing okay, and I'm not losing anything, and then this one hand comes up, and this is the hand that we're going to be talking about today. I look down at these cards. I have a Jack of Hearts and a Jack of Diamonds. By the way, this is a true story. So this over here represents the dealer's deck. Right, there's 52 cards in a deck, 4 suits, all of the different values, and I'm looking down at 2 red jacks. So I'm just going to remove these from the deck right over here, because we know that they are in my hand and not somewhere else. Okay, the Vegas guy. Big scary guy across the table from me. This guy looks like he knows what he's doing. He plays poker all the time. And he's playing really aggressively. He's betting a lot of money every hand. The kind of guy that I really don't want to be playing against. But I have a good hand. So I pay a little bit of money so that I can see the first 3 cards turned over. And what happens next is the dealer puts some cards on the board that are going to impact my hand. And I don't know if you guys know the rules of poker, but think about it really straightforward. Pairs are good, 3 of a kind is better, 4 of a kind is best. And we'll talk more about some of the other hands in a second. So the flop is the name of this part of the game. And this is what it comes down to. There is a King of Hearts. There is a 3 of Spades. And there is a Jack of Spades. So what do you guys notice? I have 3 of a kind, right? So the Jack of Spades is gone, the 3 of Spades is gone, and the King of Hearts is gone too. So the deck is a little bit thinner now. There's fewer cards out there. Okay, so I'm feeling pretty good about this, right? Because I have 2 jacks in my hand, 1 jack on the board. That's 3 of a kind. That's a pretty good hand. I think I have a shot to win this. And big old me and Vegas shark guy is betting tons and tons of money to the point where right out of the get-go, right? I don't have a ton of money on the table. This guy does. I find myself all in. $100, and all my money's on the table. So we flip our cards over. It's just me and this one guy I'm playing against. And so I see what he has. And so what this guy has in his hand is the Ace of Spades and the King of Clubs. Okay, so he's betting a lot of money because he has a king and another king, and he thinks that's the best hand. But I have 3 jacks, and that's a better hand. So at this point, this guy across the table from me is rubbing his head like, no, why did I make that bet? You're going to win all my money. And I'm thinking like, okay, this could turn out pretty well for me. And so the cards start coming down, again. So more cards come down. Did I remove his cards here, by the way? No. Ace of Spades, King of Clubs? Yeah. And you guys are following what's going on with the deck here. Okay, next card comes down. It is the 7 of Spades. And now there's one more card. Guys, what card do I really not want to see right here?
The king.
So we'll talk about the spade in a second, but the king, Thomas, why not?
Because the jack is lower than king.
Exactly. So if he gets another king, then his 3 kings beat my 3 jacks. Question is, probability students, what are the chances of that happening? Did I remove the 7 of spades? I probably should.
Okay.
Okay, first off, I'm trying to avoid what happening here. A king. How many kings are left in the deck?
3.
Careful. Here's one.
Oh, wait.
Here's one. 2 kings left in the deck. Out of, and you count 44. How'd you get 44?
45. I counted 45.
You just actually counted all of them?
Yeah.
Cool. I did the backwards thing. I was like 51, 50, 49, 48. Right? And what is it? It's 44 or 45?
45.
45? There's 8 cards counted for. 52 minus 8. Wouldn't it be 44? 44. So 2 out of 44. Simplifies to 1 out of 22. Who's going to win this hand? Should be me, right? Yeah, you guys know what happened? He got the king. Of course he did. He got the king on the very last card, and I lost all my money. But what you guys have here is a simple probability, right? The number of kings out of the number of cards remaining in the deck. And that's how we figured that out. But there's a complication. Jacob, what was it? Spades are also a problem. Why?
Yeah, they're the same suit. You get like
It's called a flush. So if you're not a poker player, that's why this is up here, there's a higher hand called a flush. And that's if you manage to get 5 cards from all the same suit. So notice that spades, 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 and spades. This guy has 4 spades. And if he gets a 5th spade, he'll beat me with a flush. And if he gets a king, then he'll beat me with 3 of a kind. So there's actually 2 ways for me to lose this game. And I want to draw your attention to this other board right over here, to a Venn diagram. You guys have seen these before in science classes, and you understand the most part how they work. On the left-hand circle, this is beat cutter with 3 kings. And we already talked about that. What cards would beat me with 3 kings if it's the last card dealt?
The king.
These guys down here, right?
Yeah.
The king of diamonds and the king of spades. So I'm going to put that one right there. So kings, right?
Mm-hmm.
This circle over here is how he beats me with a flush. By the way, what is the probability of that happening?
1, 2, 3.
How'd you get that? Counted what? 9 spades. And why 44? 44 cards, right? Okay, fantastic. So if a spade comes down and there's 9 of those, I'll also lose this game. So 9 spades, let me draw my spade here. So all of the spades right there. So what's in the middle?
The king of spades.
The king of spades. Why?
Because it's both a king and a spade.
Because it's both a king and a spade. If that card comes down, I lose because he has 3 kings, or I lose because he beats me with a flush. So my question for you is, what's the probability, 1 out of 44, that the king of spades comes down? What's the probability that I lose? I mean, like the overall probability. Doesn't matter how, but what's the probability that I
10 out
lose?
of 44.
How'd you get 10?
Because 9 spades and 1 king from a different.
But I thought there were 2 kings that mattered.
No, but then it's counted in the spade.
So probability of me losing, Jasmine says, is 10 out of 44.
Yeah.
But that's just using spades.
But over here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
But there were 2 out of 44 here, and 9 out of 44 here. Shouldn't that be 11?
No,
Yeah.
because it's the same card that pertains to both of the categories.
Because we would be double counting the king.
Yeah.
Exactly. And that is the exact principle that we are learning here in this unit. So it's the probability of compound events. And so if you guys have some notes out, go ahead and jot this down really quick. I'm going to put this right up here. Probability of compound events. And I'm going to give you guys a formula for this. It would be the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. So this right here. Okay, so to put this in perspective, relating back to my problem here, A or B? A is I lose to 3 kings. B is I lose to a flush. So what's the probability of me losing? Doesn't matter how. The probability of me losing to 3 kings, which remember was 2 out of 44, plus the probability of me losing to a flush, which was 9 out of 44, minus the probability of both, which was 1 out of 44, and that was that magical special card, the King of Spades. So 2 plus 9 is 11, minus 1 is 10 out of 44. If we wanted, we could express that as percentage, we could reduce it, but what's the moral of the story?
The odds are
Supposed to be unlikely.
Well, the odds were with me, but
Gamble.
yeah, the moral of the story is don't gamble. Even if you understand the probabilities, there's too many other things that can go wrong. Question?
So essentially, you have a higher percentage of getting beat by the king of spades instead of the king or the spades by themselves.
Well, I'm more likely to get beat by just a spade, because right there are 9 spades, 9 different numbers here, so 9 of them, 9 ways. There's only 2 ways for me to lose to a king, but one of those ways is already a spade. You understand what I'm saying? Because the king of spades, so it's this one here in the middle.
How come there's a 10 out of 44 chance of you getting beat by the king of spades?
No, there's a 10 out of 44 chance of me losing. There's 2 ways for me to lose. 9 out of 44% chance that I lose to a spade, 2 out of 44 chance that I lose to a king, and then I have to subtract 1 because the king of spades fits into both categories. So we don't want to count that twice.
I just wrote that.
To see it even a little bit more clearly, if we look back at the deck of cards right over here, we're just looking for different cards that can beat me, which is anything in this column, 1, 2, 3, 4, 5, 6, 7, 8, 9, or this guy right down here. But if any of these cards come up, any of these cards come up, or any of these cards come up, I'm fine, I win. It's just these ones that kill me, and that's how we calculate the probability. Questions? Cool. Will you pause the video, please?